Start our session?
Yeah, sure, ma'am. We can start.
Okay, sir.
Good morning, all. Hearty welcome to QUAESITio 22-23, Multidisciplinary Online International Conference, Department of Good morning, all.
Chief guest, Dr. Shailesh Sivan, Computer Science Department HOD, Sri Manoj K. Yashod, teachers, students, and Computer Science CUSAT, who deliver the talk on Converging Data Science and Machine Learning, Thought and Realities to this event. I am sure that you will feel enriched with knowledge after the completion of this session.
and Realities.
Okay, thank you. Thank you for the nice introduction as well as inviting me for this particular keynote, science and machine learning, thoughts and realities. Okay, so myself, Dr. Shailesh, working as an assistant professor in Department of Computer to have a science like data science dealing with data. Okay, so simply a data is nothing but it's a discrete objective facts or observations which are unorganized and unprocessed and therefore have no meaning. I'm telling like Shailesh, computer science, assistant professor, Department of Computer Science, QUSAT. Okay, these are all raw facts, but they are not connected and will not specify or will not convey any kind of meaning to the information. Okay, we can call it as an information, like Shailesh working as an assistant professor in Department of Computer Science, QSAT. If that statement conveys a meaning, right, rather than simply saying nothing but the facts and the information from the facts, that is the data, and from the informations, and how can we apply this knowledge into a real-time situation to solve a problem. That ability of a human is actually called as wisdom. To convey for attaining the wisdom, what should be the core foundation we should have? That is data, right? So why data is important? To problem and back up your arguments, and with the data we can be strategic in your approaches for doing a particular task, and we can keep track of it all and know what you are doing well. This is definitely what will be the answer. The Google, Netflix, right? Google, Netflix, Facebook, Meta, Microsoft, right? These are the companies. Okay, and just think what are the commodity they are dealing with. They are back in 2005-6 time. We can see the commodity that control the entire world economy is what? It's crude oil or the petroleum products, right? But nowadays we are drowning in data but starving for insights. Okay, that is, we are drowning in data. We are having data around us everywhere, but we are starving. Okay, so a data science is nothing but it is a field that deals with every aspect of data. Okay, so you might be confused with this Venn diagram, right? Artificial intelligence is another domain, machine learning is there, data mining is there, deep learning is there, neural networks are there, deep neural networks are there. There are different areas of expertise, and as a as well as differentiate these domains. Okay, So before getting more into the field of data science, we can now discuss about what are the different areas of interest now we are seeing in this Venn diagram. Okay. So artificial intelligence. When you come to artificial intelligence, see now completely depending on computers in different forms, right? So even if it is a dumb device, we are relying upon computers in a very large manner. What is the reason for that? If you look into the reason, dumbness of computers, if you can remove the dumbness of computers along with the properties, speed, accuracy, and versatility, these computers can do wonders, right? Or it can do systems. Okay. So using artificial intelligence, we can make a system. The system can be a computer, a laptop, an embedded device, an IoT device to become intelligent. In that way, in artificial intelligence also, we have different domains like predictive analytics, machine learning, speech analysis, and using audio signals, so audios and sound signals to make a system intelligent. And in the case of computer vision, they are using visual perceptions. And in the case of planning and optimization, we are doing some kind of mathematical models to make a system intelligent. And in the case of robotics, it is a analysis, computer vision, natural language processing, robotics, right? And so nowadays we are telling artificial intelligence is equivalent to what? Machine learning. Okay. And subset, there is a family of algorithms called artificial neural networks, which depicts the working of a human brain for making decisions. That type of algorithms, family of algorithms, are actually called as artificial neural network. And within artificial neural network, as a deep neural network. And if you're performing machine learning with this deep neural network, we can call it as a deep learning technique. Okay. Now you are able to connect this, right? We have the upper domain artificial intelligence. Within that, we have machine learning, and within okay. Now come to the next bigger domain, that is our area of interest, that is data science. So what is data science? Data science, as the name suggests, it is a science that dealing with data, right? Uh, collected somewhere in the form of web servers, databases, logs, and all. That process is actually called as data acquisition. After data acquisition, we have to prepare the data used by descriptive and predictive analytics, and then using that, we will apply some kind of prediction, or we will model some kind of forecasting and prediction systems. Then we will visualize the results of the source data will be in a structured or semi-structured or unstructured form. We will inject the data into a data storage. After that, we will clean the data, transform the data, and analyze the data. Then we can realize a data science pipeline with a single in the data. And we need good data engineers in the case of data cleaning and preparation. And we need people with good mathematical and statistical skills for analytics. And again, we need software engineers to build models upon this particular analyst. Since this is very fascinating, this is also the most demanding area in the stage in data analyzation's next step. Okay, that is according to these needs. The data analytics is actually categorized into four. The first one is descriptive analytics. The second one is diagnostic analytics. Third one is predictive analytics. The last one is prescriptive analytics. Okay. So in the case of descriptive analytics, see, in the case of descriptive analytics, we are trying to find out what happened. Okay, we are trying to find out what happened. Okay, so like we are having a data. Okay, and like as in the example, information on new client data, win rates, and goals are there to customize what happened. Okay, and in the case of diagnostic analytics, our concentration is to find why did it happen through descriptive analytics, we have found that something happened or something occurred with the past data. Okay. Now, in the diagnostic analytics, we are actually trying to dissect our inference and find out the reason for that particular event. That is what happening in what diagnostic analytics, and the identifying the outliers, isolated pattern identification, then uncover relationship identification. These are all the different type of use cases within diagnostic analytics. Okay. And when it comes to the next level of analytics, that is called as a predictive analytics, we are trying to find what might happen in the future. Okay, what might happen in the unknown future. So in the previous two cases, see, the people, the statisticians and mathematicians can actually do the analysis using their tools like SPSS, TAS or something, right? Or some other sophisticated tools. But in the case of predictive analytics and the prescriptive analytics, people can't do this predictive and prescriptive models with what the simple tools like STAS or SPSS or Excel kind of stuff. So they have to rely upon the techniques included in artificial intelligence and machine learning to effectively build predictive models. Okay. And the last one is prescriptive analytics. Prescriptive analytics is nothing but they are actually the recommendation type of analysis. Like from the prescriptive analytics, we found that this event might happen. Okay. So in the diagnostic analytics, we will suggest according to our need and the result obtained using prescriptive analytics what to do next. Okay. So that can be in a positive way as well as in a negative way. Okay. If we are actually inferring that our company is going to be in a loss for the next 5 years. Okay. Then it is a negative inference, but we can actually suggest what all things we can do to make that will not make happen. Okay. And in a positive way, we are predicting that in the next 3 years we are having a profit of 55%. So according to get that 55% profit, what all things need to be do. That is the recommendation we are doing to the company. Okay. So prescriptive analytics are mostly giving recommendations according to the need or the actions happening in the predictive analytics. Okay. So these are the 4 different type of analytics, and very clearly you should understand that in the first 2 phases, descriptive and diagnostic analytics, we can simply use tools, okay, software tools to analyze it in an efficient way. But when it comes to, we must talk about the big data and data analytics because it's a part of it. Okay, and we can consider it as another large domain. Okay, so big data. So what are the reasons for big data? Because we are
നമ്മുടെ ഈ ഡാറ്റകളൊക്കെ, അതായത് ഇപ്പോൾ നമ്മൾ എന്തെങ്കിലും സ്ഥാനത്തെക്കുറിച്ച് സെർച്ച് ഒക്കെ ചെയ്ത് കഴിഞ്ഞാൽ അതിനെക്കുറിച്ചുള്ള റെക്കമെൻഡേഷൻസ് ഇതിനെ വന്നുകൊണ്ടിരിക്കുന്നു.
Yes, yeah, anything can be big data. Okay, so usually people will think like the large data volume is one aspect, velocity is another aspect, variety is one aspect, veracity is another aspect. Okay, and the largeness of the data is only dealing with volume. Okay, so how the volume become a constraint while doing the computing into 2, and on an average the flight flies for around 6 hours a day. So the total data generated by a single flight is 20 into 2 into 6. Provides such infrastructures to accommodate large data as well as computing techniques to analyze this much of huge data. Okay, a server system which is deployed in US or UK, right? So data is always moving. Okay, so when data is moving, definitely for us. Okay, and from a single camera it will be around 30 frames will be captured in a second, right? So how much frames will be arrived at the computing environment if they are, this is not a big volume, but the requirement of analyzing this 3000 image the single moment become an issue. Okay, that is why the velocity become an issue in the case of big data. And if the velocity is very high, we can call, in that case, I need to analyze textual information at the text itself in a English, Manglish and Malayalam, right? The audio, the emojis, the stickers, the videos, the documents, the location. Okay, so many data will be shared, right, within the small environment of WhatsApp itself. So analyzing this kind of huge amount of different type of data and finding an inference is difficult, right? So that is why the variety become an issue for data analysis, and big data also solve this variety problem. And the veracity is most making a decision, then the veracity will tell you whether it is reliable or not. Okay. So these are the different aspects of big data. There are other V's like value kind of stuff. And these 4 V's are the most important 4 V's. Okay. And when it comes to the tools we are using for data analysis, see, you can see a variety of tools, right? See, start PSPP, SAS, Excel, Python, Tableau, Power BI, Data Studio, Minitab. There are a variety of tools we have for data analysis, visualization, and dashboard development. And when it comes to the big data area, we have Spark, Hadoop, HBase, Kafka, Solar, Elastic kind of areas. And when it comes to AI ML, we have different tools that Jupyter Notebooks, SciPy, NumPy, Dask, Bokeh, Scalar, NumPy, TensorFlow, Pandas, PyTorch. These are all different tools available for AI ML building. Okay. And our topic is like how we can converge data analysis and machine learning into a single point, right? Machine learning and data analysis into a single point. So we have now at some task T with experience C. That is, it can be considered as a well-defined learning task given by PTE. That is, machine learning is nothing but it is the study of a set of algorithms that improve their performance. Okay, improve their performance P at some task T with experience E. Okay, so this is a formal definition, and most of the people won't like this or won't understand this. So I will have an example. So see, you have a robot with you, and you are on the left side. Okay, you want to make the robot learn from the surroundings. Okay, and the first thing you want to make a robot learn is the robot should be able to identify a shirt. Okay, so what you will do, you will show a green color shirt to robot and telling that robot, this is the shirt we used to wear. So the robot will observe this shirt, and it will characterize the shirt as what? Red color. Okay, and it is, sorry, green color, and it is a size large, and it is a formal type of thing. So to be an object become a shirt, definitely the color should be green, the size should be large, and the type should be formal. Okay, and with this perception, if I ask robot after showing another red color small t-shirt, then it will actually compare its perception with what it is seeing now. Okay, and on comparing, the color is not red, the size is not large, and the type is not formal, and we again telling that this is also a shirt. Okay, so what will happen, the perception of robot will change, like the color can be either green or red, the size can be either large or small, and the type can be either formal or casual. Okay, likewise, if I give more shirts, okay, if I give large or small, it is medium, and it is a casual wear. Okay, only one condition is true. Okay, but again I'm telling that robot, this is also a shirt. Again the perception will change. So what will happen if I give as much example to PK shirt I have given to that robot is the experience. Okay, and what is the performance here? the correctness in predicting whether it is a shirt or the relationship as a program, and we will execute that program and we will give the data and we will get the output. Like suppose if I ask you how to calculate the area of a triangle given three sides, you will definitely say like the area will be root of s into s minus a. Transform the data into output. You know a set of inputs and output for the past few trials, but you don't know exactly how to transfer the logic. We transform that logic into program and we will execute that program and give the data, we will get the output. But in the case of machine learning, we have the data as well as the output, but we don't know the relationship between this data and output. And with the help of machine learning, we will find out that logic between input and output, then convert it into a program. So what is the advantage of this? After finding out the relationship, we can actually forecast some kind of output for the future data. And when you look into the pipeline, typical machine learning pipeline, you can see we have there are several stages in the machine learning pipeline, and it is very similar to our data science pipeline. See, we have the raw data, we are doing some kind of pre-processing, we will get the prepared data, we will apply then machine learning algorithm, we will get a candidate model, then we will choose that model to apply on a real-time situation. Okay, and the entire pipeline is actually relying upon a particular term called data. Okay, now we can now find out the synergy between the data and machine learning, data science and machine learning. See, if you are considering the machine learning as a rocket engine, then the data is actually the fuel for that engine to fly. So we can say there is no existence for machine learning without data, and there is no use of data without machine learning. Okay, so we can say these two domains, data science and machine learning, are complementing to each other. Okay, they are complementing to each other. And what are the different types of learning? We have three different types of learning, that is supervised learning, output. So we have a past inputs and outputs. We are trying to find out an f, that is a relationship f that maps an input to output. So what is the advantage of that? If you find that relationship f for an unknown future input x cap, you can also predict the output y cap. Okay, so mostly this supervised learning has two use cases. Getting a image, we are classifying it as a male or female. Okay, clear. And after getting the after getting a email, we are classifying it as a junk mail or a genuine mail. These are all different type of classifications. And when it comes to regression, what is it? It's actually a classification task, and with the details of a student, we are trying to find out what will be the percentage of mark obtained by a student. Then it is a regression task, right? So that is the difference between classification and regression. And when it comes to unsupervised learning, the difference is like we are not having the labels, right? So without labels, what can we learn? We are always trying to find out the relationship between input and output, but here the output is not present. So in this scenario, what we are trying to learn is we will find the relationship between the inputs. Okay, find the relationship between the inputs. So after finding the relationship between inputs, you can actually do some kind of clustering. Okay, clustering that makes a group of objects into several groups according to their similarity. And the other one is association rule mining, that is with the transactional data bases, we can actually find out commodities that buy together. Okay, so like in the case of bread and jam, in the case of shoe and socks, that kind of relationship identification is actually called as what? Item set and association rule mining. Okay, so all these things can be done with unsupervised learning. And the third one is reinforcement learning. Reinforcement learning is nothing but it is kind of agent-based learning, or it is trying to increase the reward of a particular algorithm by doing the task by that algorithm in a proper way. Okay, so we have an objective. The algorithm or the program should do that objective, and we will observe the result obtained through the process. Then if the algorithm is performing that particular objective in a proper way, we will give a good token, otherwise we will give a bad token. Or getting the good token, the algorithm will again and again do the same thing, and finally it a that program become able to do the task in a proper way. Okay, that is the kind of reinforcement learning we have. Okay, and there's another type which it is not much explored now, because it's a combination of supervised and semi-supervised learning. Okay, so now you have understood what is machine learning, what is data science, what is big data, everything, right? What are the things that happening in that? Okay, now how we can induce intelligence in analytics? Okay, artificial intelligence have a synergetic relationship, because AI requires a massive scale of data to learn. AI as well as machine learning requires a massive leverage advanced analytics. Okay, and in the case of big data analytics, we have used two major tools. First one is Hadoop, and the Spark systems or the Spark architecture to analyze the big data. And when it comes to the Spark architecture, you can see there is an essential library called MLib. Okay, MLib. Usual machine learning and big data machine learning is, in the case of usual machine learning, we are doing it as a single process. Okay, single process, but here it is actually implemented as a distributed way. Okay, so it is not a big deal to have a parallelized execution path, because it will be handled by the library itself. Okay, and we have two different types of parallelism. First one is model parallelism and the data parallelism. In the model parallelism, the model will be distributed over different systems, and we need not to keep different data on different machines. But in the case of data parallelism, here we have the same algorithm on all machines, but we will keep different group of data at different machines. Okay. And why this MLib is? It is compatible with Java, Scala, Python, and R. The performance also is 10x faster than the simple MapReduce, and it is compatible with any type of newer deployment tools. Okay, and definitely when we're talking about machine learning, we should talk about what deep learning also, because deep learning also helps a lot in the case of big data as well as simple data analysis. So in the machine learning, we have the input. We should identify the feature engineers and then do the machine learning task to get the output. Okay, but in the case of deep learning, see here, the feature engineering as well as the machine learning stuffs are done by the network itself, so user is not much confused with this. Okay, so we are using deep learning nowadays to effectively analyze the model, and this deep learning again is available as distributed deep learning for apply on Apache Spark, like big data processing tools. Okay, like LFS, CERN, Intel Analytics, Big DL, Apache Spark, System ML, Keras 2D ML, Database, Spark Deep Learning, Yahoo TensorFlow on Spark. These things are actually nowadays available to effectively process big data with what deep learning technique. Okay, so that's the end of the session. See, we have big data science as a domain, and we have artificial intelligence and machine learning as another domain, and they are actually complementing to each other, and they use tools in between for effectively process the data, and as well as to effectively build the machine learning model. We need data too. Okay, so At the end of the day, if you look into the pipeline of a machine learning or a data science or an artificial intelligence or a big data project, you need to converge your ideas and expertise from data science as well as in the AI/ML domain to effectively build a final model. Okay, so that's all for today's session. I have limited it in 1 hour, and maybe it was quite fast, I think. If you have any doubts or something, you can ask. We have a question answering time now. Is there any doubts?
Sir, I have a doubt.
Yes.
It's regarding is big data and market basket analysis the same?
No, there is actually a particular task in big data analytics, which is called as association rule mining.
Okay.
Association rule and item set mining. And market basket analysis is another name for this.
Okay.
Item set and association rule mining.
So it comes as a sub under the big data.
Big data as well as in the data mining.
Okay, sir. Then, sir, there is one more doubt.
Yeah.
Sir, is classification and analysis done at neurons?
Yeah, we can have different algorithms for performing classifications.
Okay.
There's an algorithm called support vector machine. There's an algorithm called naive Bayes algorithm. There's an algorithm called KNN. There's an algorithm called decision tree. There's an algorithm called artificial neural network, particularly perceptron and multi-layer perceptron. All these algorithms are actually can be used for classification.
Okay, sir. Then, okay, sir.
Yeah, but when it comes to deep learning, we are using the perceptron models, that is the neural network model for classification.
Okay, sir. Thank you.
If anyone wants to clear any doubt, please ask to sir. I think nobody is there.
You can freely ask in case of any doubts or any other real-time situations that you are facing in the AI/ML domain.
Sir,
Yes.
sir, can you explain where we are using this reinforcement learning?
Yeah, reinforcement learning is actually used in a situation where we need to learn. We don't have the data at the beginning. Okay. We need to learn from the circumstances we are deploying our project, like the robots.
Okay.
Suppose if you want to create a robot that should be deployed in a a constrained environment, and the robot need to place a commodity from one place to another. Okay, he should be first deployed in the environment without any knowledge. Then he will start learning from the environment, where the blocks are, what is the correct path, where we need to go to the next step. These things are actually learned from the circumstances. So there we can use reinforcement learning. In other cases, in the classification clustering cases also, we can use reinforcement learning, and there are specific algorithms called Q learning kind of stuff in the case of simple tasks with reinforcement learning.
Okay, sir. Thank you.
Any other one? Okay, sir. Let's conclude our session.
Yes, ma'am.
Thank you, sir, for sharing this valuable knowledge about data science, artificial intelligence, and data analytics, etc. So now let's begin our paper.
Our paper presentation competition will start within 5 minutes. All participants, are you ready?
Our first participant is Miss Anjana TK, Department of College, Devagiri.
Shall I start?
Okay, start, ma'am.
Okay.
You can start, ma'am.
Okay. Am I audible?
Yes, ma'am. Yes.
Okay. Good morning to one and all present here. Myself, Anjana TK, Assistant Professor, Department of Computer Science, St. Joseph's College, Devagiri from Calicut. Today, I am going to present a paper on the topic Identifying Depressed Users in Twitter by Improving Feature Selection. So, I'll be moving throughout the session to the topics like introduction, the existing model, proposed system, and conclusion. So before going into the topic, the depression is one of the most common mental health disorder nowadays, and it is very difficult to diagnose a person with depression. And here in my paper, I am proposing a social media and evidence like social media networks. Data from social media network provide valuable informations about a user and whether he or she is suffering from depression. So here I will be talking about machine learning concepts that are used to diagnose depressed users, especially in Twitter. So before going into the machine learning concepts, we'll discuss about machine learning. What is machine learning? Machine learning is actually the capability of a machine to think and act like an intelligent human being. So that is the formal definition for machine learning. So machine learning processes includes mainly two steps like pre-processing of the data, and we'll be having feature extraction from the data. So here data is the most important material or most important input to our system. So during pre-processing, or what is the use of pre-processing? Pre-processing is actually making our data into more meaningful. Usually we'll have the raw data which is very inconsistent and will be error prone. So in order to make our data more meaningful, we'll be using the first step of machine learning model, that is pre-processing. So pre-processing will make our data complete, consistent, noise-free, and error-free. So after pre-processing of our data, then the next step is we'll be feeding our data into for the feature extraction. So feature extraction means it is actually the measurable property of a phenomenon. For example, the feature of a human is like it is a measurable property of a phenomenon. Like for human being, it will be age. Age is a feature for that particular human being to identify that particular human being. Gender is another example for feature for that for identifying that particular human being. So these all are the feature for a human being. Likewise, you have a feature set for a data also. So here we are considering the data from the Twitter. So this is our existing model. So far we discussed about the main steps of machine learning and what is pre-processing and what is feature extraction. So here we are feeding, I already told, like we will be dealing about Twitter data. So here we have the Twitter user data log, which we'll be feeding as input to the data preprocessor. So data preprocessor will make our data more complete, consistent, and it is then fed to the feature extraction or feature set. So here for Twitter, we have categorized our features into three. The first one is user profile feature. Second one is social interaction features, and third one is linguistic feature. So our aim here is to find out the users who are suffering from depression. So from user profile features, we can extract features like follower, like people who receive your tweets. So all those will come under your followers list. Then listed count. Listed counts means it is the number of public lists that the user is a member of. That particular user is a member of this particular group. So you get all those informations from your listed count. Then friends, how many friends, and then total favorites, like number of times the tweet has been posted. All those things, those informations you will get from your user profile features. So from user profile features, we are just extracting, the existing model is extracting all these features. And in the case of social interaction features, this is actually the communication part of the user, like how many mention counts, like you can mention people in your tweets in Twitter. So how many whom all you have mentioned, the post count, how many posts you have posted, then retweet count, how many retweets you have given. All these informations will be extracted in the second category, that is social interaction features. And in the third category of feature, you will be extracting the emojis, emoticons, how many negative words this particular user has used, how many positive words this particular user is used, LDA topics, etc. So all these things will be extracted in your linguistic features. So after pre-processing of your data, it will go into the feature extraction, and in feature extractions, all the wanted features are extracted, and then it is fed to the classifier or algorithm for the prediction. So this is the existing model. So in the proposed model, like the existing model, there was of course like the predictions were not accurate, or the performance were not was not up to the grade due to the selected feature sets, that is all these features. So in my proposed model, I have proposed 2 to 3 features extra to improve the performance of the classifier. So here you can see same like in the existing model, there are 3 categories of features. Like first one is user profile features, and inside the user profile features there are 2 more features I have added, like age and gender. So it is like the studies shows that the women are more prone to depression compared to men. So it is always relevant to get the gender as a feature to decide whether a particular user is depressed or not. If it is women, the probability of depression is more compared to men. And also, if you take age as a feature from user profile features, the people above 45 years are more prone to depression than below 45. So these two features are newly added in our proposed system. And also in the case of social interaction features, the status of the users. The users might share several statuses. So from the statuses also you can identify the mood of that particular user, and you can also get an you will get a result like that particular user is depressed or not. And then I have also added the profiles recently unfollowed by that particular user. If a profile is being unfollowed by that particular user, there might be something that hurted that person's feelings. So he might have unfollowed that particular user. So that is also another feature that helps us to identify that particular person is depressed or not. So these are the features I have proposed in the model to fed into the classifier. So that is the proposed model. So that is the conclusion of my paper. Like apart from the usual features, here we have added age, gender, status, and user profile features. So these features extracted from the tweet content are more important for accurately predict the depressed users. Thank you.
Thank you, Ms. Anjana. Then our next participant is Ms. Kavya Madanan, Department of Computer Science, Christ
Anu,
Nagar
wait.
College, Marinagar.
Anu, wait. Anjana ma'am,
Yes, ma'am.
can you tell any algorithm used for your proposed model?
We can have any type of algorithm, like any supervised learning algorithms can be used, or unsupervised learning algorithms can be used. As of now, we can use out of these two type of learning algorithms, any algorithms can be used.
Okay. Akash, is there any?
Hello.
Okay.
Yeah.
You can ask question.
Anjana ma'am, can you hear me?
Yes, ma'am. Yes. Yes.
Including actually how
Sorry, it's not audible.
including that feature. Hello, audible?
It is audible, but it's not clear.
Not clear.
Hello.
Can you put it in the chat, please?
Yeah, I'll put in the chat. Just 1 second.
Yes, Akash. Actually, I haven't implemented this. This is my proposed system, and this is my PhD research proposal. After completing my PhD only, I can assure you that the accuracy will be acquired. Okay.
Okay, ma'am.
Okay.
I have a
Okay.
question too. Why use Twitter and not any other social media
You
platform?
can have any social media platforms, but I here concentrated Twitter. Actually, you can use any like Facebook, Tinder, anything can be used for this particular model.
Anu, ഇത് കഴിയുമ്പോൾ വിളിക്കാം.
Then why choose Twitter? Is there any specific reason to choose Twitter? Why not WhatsApp or any other Facebook, like daily use? social media platforms?
Nothing like that. Like I concentrated, like if we have concentrated on something, you will get almost all the related, you can concentrate on the data of that particular social media. That's it. Nothing like that. Like you can have any, like one of my student is doing a paper on Facebook and other related social networks. You can have, like, when the data set is available, you can use any social media network.
So it's just randomly
Yeah.
chosen.
Yeah.
Okay, thank you.
Okay, ma'am. Thank you.
Thank you.
Thank you, Ms. Anjana. Then our next participant is Ms. Kavya Madanan, Department of Computer Science, Christ Nagar College, Maranello.
Good morning, Anadol.
Good morning. Your time starts now.
Is my screen visible to all?
Yes, it's visible.
Okay, good morning. Today I am presenting a review on remote sensing image segmentation advances in meta-analysis. Let me introduce myself. My name is Kavya Madanan, PG student, Department of Computer Science and Applications, Christ Nagar College, Manadu. My contents include introduction and the methods used in the paper and the conclusion. First of all, let us see what is remote sensing. It is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation distance. As we know, today a lot of images are getting generated. Remote sensing is used to generate the particular image or particular characteristics, physical features of an image from high distance. The advances in remote sensing sensors during the last decades have led to the production of very high spatial resolution multispectral images. The remote sensing sensors helps to generate a lot of high resolution images nowadays. In order to adapt this rapid development and handle this data, object-based analysis has emerged. In remote sensing image generation, image segmentation is basically one of the methods implemented for the analysis purpose. Also, it includes classification and other features. The main one is it improves the classification accuracy. The methods included in the papers are image segmentation methods. Image segmentation is the process of breaking down the images into subgroups called image segments, which helps in reducing the complexity of the image to make further processing. Image segmentation method is done to understand more deeper about the characteristics of the image we acquired from the sensors. The next method is meta-analysis of image segmentation applications. Here, the object-based methods are implemented in the meta-analysis. Since object-based image analysis is done because it helps to get a better overview about the image for a better prediction. Next, semantic segmentation by using the neural networks. In semantic segmentation, it mainly uses the fully convolutional network feature, that is FCN is mainly used for the purpose of semantic segmentation. Because FCN makes the training more efficient and input size of the inference arbitrary. Because FCN helps to understand the image more efficiently because it uses certain methods like segment and unit for the understanding. Next, graph model. Graph model is used for the representation of the image we acquire. From the representation of the graph, we could understand which type of data sets or variables are used in that image. Also, in graph model uses undirected graph that describes the distribution of random variables. Next method is building footprint extraction. Building footprint generation is currently existing a great deal of interest and is an active field of research in the field of remote sensing. In remote sensing, the building footprint is basically an important method for understanding the images we acquire. It is mainly used for analyzing the appearances, such as building footprint is used to understand what type of population or what type of things located in such an area, in that particular area. The below figure is such an for example for the building of footprint extraction. Here, the image is accurate and is converted to understand what type of localization or urbanization is taken there. Also, we use some methodologies like DSFE and GGCN framework. These methods are used for generating the graph. In this framework, it represents a 2D grid in which each pixel represents a node. The vectors are computed from the node inputs and by using those inputs, we understand what is represented on the graph and what type of data is used for that representation. For this, the high resolution image is downloaded and is converted to full size images and then represented graph as shown in the output figure. Why we need remote sensing? Remote sensing is needed because it contains a lot of applications like in agriculture, forest mapping, weather assessment, civil engineering study, etc. In these fields, the main focus is to collect the image and understand what things are happening there, for get a better understanding of for improving the details in the living of that area. In this work, we developed a novel framework for semantic segmentation that combines the deep structure framework, feature embedding, and a graph convolutional network. Thus, we can conclude that from this session, the neural networks are used, but the best neural networks are RNN and GCN. RNN with GCN. RNN is nothing but recurrent neural network, and GCN is graphical representation networks. With the help of these neural networks, we could extract the building footprint extractions are effectively extracted and represented in such a way in the graph to get a better knowledge about the data. Here, by using this network, we could easily represent or understand the unstructured data that we collected from by using the remote sensing sensors. That's all. Thank you.
Is there any question?
Yes.
You can.
Is it due to drawbacks in present remote sensing that you came up with this research topic?
Actually, I presented a review on existing papers. In this paper, the best methods are chosen. Actually, there may be some drawbacks because the main thing is the images are collected from sensors, no? So best neural network should be chosen to understand to analyze and learn more about the image collected.
Okay, then what improvements are you suggesting? Have you got any idea, something like that?
From this review, I got to understand that the best neural networks like RNN can be used because it gives us it is independent of the data problem. That is, it is not depending on the problem of the data collected. So we can get a better knowledge about the data. As the applications say that it is mainly used in many fields like agriculture and military services. By taking the applications, it is understandable that it is more important to use the best network to understand or to analyze the image that collected from the sensors.
Okay, so its main application is going to be in space science.
Yes. You can say.
So in satellites and all.
Yeah.
Okay. That's all. Thank you.
Thank you.
Thank you, Kavya.
Thank you, ma'am.
Our next participant is Mr. Gautam, Department of Computer Science, Christ Nagar College, Maranelore.
Gautam, are you ready? I think Gautam is not here. Gautam or Sriraj?
All of them are not in the chat.
Okay, we will call the next participant.
Okay, our next participant is Mrs. Abhirami Shashikumar, Department of Computer Science, Christ Nagar College, Maranello.
Abhirami or Christo? Are you ready?
Yes.
Okay.
Okay, good morning. Myself Abhirami Shishkumar. I am pursuing my Masters in Computer Science from Christ Nagar College, Trivandrum. I have done this paper on the topic Future and Deep Learning. So before moving into deep things, we can first see what is this AI, ML, and DL. These three technologies are connected but cannot be used as synonym. There is actually a difference between these three terms. AI means it is just intelligent machine things. ML is the subset of AI that help to build these AI apps. And DL is a subset of ML which uses large amount of data and complex algorithm to train a model. Among the three, DL is the most advanced technology. So we can discuss about what is deep learning. So deep learning is a subfield of machine learning where artificial neural network work in a similar way, similar to human brain. So DL is basically focusing on training computer to mimic how we people learn things. As humans, we perceive information from text, images, speech, not only by using our sense organs, but also a network of neurons in our brain. Millions of neurons exchange electrical and chemical signal and transmit in this way. Here, artificial neural network pass information similarly. They do that through multiple interconnected layers consisting of neurons. In deep learning, the so-called depth typically refer to the neural nets having more than 3 layers. Sometimes it can be 100 layer actually. So now we can see how deep learning algorithm work. For example, here is an image of horse. Even if you have never seen this image before, we can recognize the animal actually. The fact that the horse may be cartoonish or something like it is dressed up, there will not be any difference at all. You can recognize a horse because you know well all the defining elements such as the form of its head, body, and so on. Here, machines can only see numbers that represent individual pixels, not as an object whole. That's why such straightforward tasks telling a horse from a zebra or some other animals may be quite complex for the machines. When
Abhirami,
we talk, yes.
Abhirami, change your slide, please.
Okay, while we talk about AI resembling human intelligence, existing AI systems are not near our cognition. So we can see how deep learning works. So deep learning relies on neural network to solve a variety of problems from simpler classification tasks to more complex ones. The input data goes through multiple processing layers of artificial neuron piled up on the top, one another to provide output. So what are these neurons and how exactly they connected? We can see. The picture here shows a typical multi-layer design of neural nets. There are three layers actually: an input layer, hidden layers, and output layer. Input layer is the first layer that loads data into a model and passes it without any computation or operations. Hidden layers, it's a multiple interconnect layer that perform mathematical operation on data. There will be many hidden layers. I just took only one. Here is the final layer which provides the result by taking input from preceding hidden layers. So if you want to create a neural network capable of recognizing the horse and zebra in pictures, the data set will consist of numerous image showing both animals with each other made up of a certain number of pixels. So each pixel will have a corresponding neuron in the network layer. So generally, they receive input signal from the set of raw data or form neurons of a preceding layer. Then do some calculation on the signal received and send output signal to neurons residing the subsequent layers. So basically, what is neuron? They are just individual nodes that are responsible for a data flow and computation. Some of etc. Every neuron holds a number that shows the value of a certain variable. In our case, the pixels, the pixels. So the activation in one layer, the activation the synapse is enable the transmission of activation from one node to another. It's a link. Actually, synapses is the link. Similarly, synapses also have weight that determine the activation number. So activation function means
Abhirami?
when the input from the neuron.
Excuse me,
Yes.
Abhirami. സ്ലൈഡ് ചേഞ്ച് ആവുന്നില്ല കേട്ടോ. ആ ഹെഡിങ്ങിൽ തന്നെ നിൽക്കുകയാണ്. ബാക്കിയുള്ളവർക്ക് ആ സ്ലൈഡ്സ് ഒന്ന് കാണണമെങ്കിൽ ഓക്കെ.
മാം ഇപ്പൊ കാണാം മാം.
പ്രസന്റ് ആയിട്ട് വരുന്നേ ഉള്ളൂ, നോക്കട്ടെ. ഓപ്പൺ ആയില്ല കേട്ടോ.
Now visible?
Yes, yes. Okay, okay.
So now moving on to the activation function. When the input from the neuron find the target neuron, the neuron will multiply each input by the weight and passes their weighted sum to activation function. There are also bias numbers added to weighted sum to better predict in different ways. The final output represents how strongly a system thinks that a given image shows a horse or a zebra. So some of the applications of deep learning are computer vision, image recognition, speech recognition, fraud detection, etc. Another important term regarding the deep learning is transfer learning. It's a cool thing actually. Here we don't have to train a neural network from scratch. Neural network that has been trained on one task can be used it on another, but it should be a related problem. So by saying that, so deep learning or deep neural network have received the majority of research over the last 10 years. So is that the end? I think there is something, or there is something, anything beside neural network that might offer better. We can wait and see whether the future is in deep or not. Thank you.
Any questions? Abhirami, check your chat box.
Okay. So activation function from when we get an input from neurons, we have to find the target neuron that to identify the features of an image. When we input an image, then these features are identified from these neurons actually. When we find that there will be many neurons actually, so from each neuron we will get a feature, so it will be added and weighted in the activation function. That will be done in that function.
Hello. Am I audible?
Yes, hello. Yes.
Yeah.
Yes,
Am I
yes.
audible? Yeah. Yeah. Exactly. Like there are different type of activation functions. Do you know like how you know how many activation functions?
No, I think it will be depend on the neural network, the hidden
Yeah.
layers and all.
Yeah, it's correct. But actually, activation function does is that it captures the non-linear function between the input and output. You can train a network without activation function also. It will work. But if you want to train a complex network, we need to use activation functions. Okay, for whenever you are choosing a problem, it depends on the problem. Depending on the problem, we will choose the activation functions. Okay.
Yes, yes. Okay.
Okay.
Okay, thank you for the information.
Yeah.
Any other questions?
Is there any specific relevant field in the present time where we can use the artificial neural networks?
Actually, now it's in everywhere. AI and ML is now into deep learning actually. So we can use it in anywhere, any kind of like from image recognition to fraud detection, etc. There are many fields actually in medical. In every field, we can use this.
Okay, do you think there is a more relevant field? Any relevant field that main focus?
I think medical field is more.
Medical field is that means the microbiology field and all like that?
Microbiology field and actually in the disease recognition also.
Okay. So actually it means that implanting those things in human brains or by machine itself.
Yes. Actually, we are creating artificial neurons itself, similar to our brain or our neurons.
Okay.
Okay, thank you, Abhinami.
Okay, thank you, ma'am. Thank you.
We can go to the next participant.
Thank you, Abhinami. Next participant is Miss Anamika UR, Department of Computer Science, Christ Nagar College, Maranello.
Good morning.
Good morning, Anambika.
Can I start my presentation?
You can start your presentation now.
Is my screen visible?
Yes, it's visible.
Okay. Let me introduce myself to you. My name is Anamika. I am a PG student of Christ Nagar College, Maranello, and my topic is analysis of effectiveness of a priori algorithm in medical billing data mining. Okay, first we go to the introduction part. In this review paper, I am telling about the finding associations between diagnosis and treatments. The algorithm is equally beneficial for finding the large item set and thus generating the association rules in medical billing data. In this paper, I am showing about the resemblance between medical bill and purchase bill is the motivation of using by using the a priori algorithms. In the main situation like in the healthcare, the applications of information technology, the healthcare domain has emerged into many private organizations to produce health related tools. Electronic medical record, also known as electronic health records, is one of the major healthcare in IT software being used by medical providers. Next one is the main adaptation of what are the main adaptation of a priori algorithms. Mainly we use the a priori algorithm for finding items that initially used in sales purchase domains. We can test it and utilized in various domains. First we can look about a priori algorithms. What are the benefits? In this algorithm, all the subsets of a frequent item sets are always frequent. When k item set is not frequent, not used in generating k plus 1 items. And there are two parts of rule generating algorithm. First part is the frequent item set having support generated than minimum support of maximum size and return. That is to generate rules from these frequent item set by finding their all subsets. When we are modifying, and then second one is the uh, modification in a priori algorithms. There are two main modifications we can do in this a priori algorithm. First is the we can modify the a priori algorithm. The second one is the modification in generating the rule in this algorithm. Next one is the prototype software. What are the things we include in the software? All the data is stored in the form of text files and loaded in the memory when software runs. The main weakness of the algorithm is that, which has not been overcome in this paper, is that the requirement of data in the memory. Front end of the software consists of main starting window and rule generation features is provided on claim window, which is also used for displaying the claims. Currently, in my proposed model, next I am telling about my proposed model. Currently, there is a single rule generating window, but during testing the need of multiple rule generation window, user can give initial international classification of disease, also known as diagnosis code or current procedure terminology code. In a priori algorithm is good in finding the frequent item set of larger size, but we want to do some modifications. In this research work, payment value has been associated with each rule. The quantitative processing can be done on the basis of any of these payment rules. Next, we can say about the discovered characteristics of medical billing data in the proposed system. First one is the small range of size of items. And that means affect the rule generating part of a priori algorithm exponentially based in the size of item sets, but it not affecting due to small sized item set. Then the second characteristic is low frequency of individual items. Billing company accumulates data from practices of different specialities of large frequencies. The data from one practice it will give relatively higher frequencies. Then the third one is regular pattern in payment values. It should be less consistent pattern. Other should paid amount appear to be more systematic and consulting patterns. Next, we are going to the future possibilities in the proposed system. There are a lot of possibilities. The first one is the multiple rule generation. It has one rule generating window and multiple rule visualization window. From one algorithm and multiple rule generating algorithm can be implemented in the multiple rule generation. Then the second one is the diagnostic decision support. It has been constrained by the depending on human inventory experts for the populations of knowledge. Then the third one is the distributed data mining. That the billing company data is collected, it can perform data mining operations by using EMR result of the data mining operations on the global database that can be sent, compared and utilized database of a single practice. Finally, I am concluding my paper. That is, some if in the a priori algorithm some modifications have been made in the algorithm to with the requirements. Higher language features may be costing some response time, and the margin of improvement in rule generations part of a priori algorithm, as currently it is exponentially based on size of item sets. The increasing the consistency of charged amount thus can improve the payment. Thank you.
You can ask question to Anamika.
Okay. What is the key concept of a priori algorithm?
The key concept of a priori algorithm is that used for calculating the association rule between objects. It means that how two or more objects are related to one another. If we have two data sets, how we can compare and how we can cluster it or forecasting it, that the a priori algorithm is telling.
There is a specific name for that key concept. Do you know that?
Specific
There's a specific name or a specific term for that concept, key concept.
Mainly in data mining, the priori algorithm is used.
Not the explanation. I just need that a term, a single term is there. Do you know it, or can I tell that?
I think no. Can you tell, please?
It's an anti-monotonicity property.
Okay, thank you.
Okay, thank you.
So thank you, Anamika.
Thank you, ma'am.
Thank you, Anamika. Our next participant is Miss Aina N, Department of Computer Science, Christ Nagar College, Maranello.
Aina, are you ready?
Yes, ma'am.
Okay.
Ma'am, shall I start my presentation?
Okay, you can start now. You can start your presentation now.
Okay, ma'am. Ma'am, is it visible?
Yes, yes. It's visible.
Okay, ma'am. Good morning, one and all. My name is Aina, Department of Computer Science, St. Joseph College, Devagiri. I'm going to present about the topic identifying depressed users in social media using machine learning model. So, what the idea behind the topic is, we use social media to detect the depression and non-depressive people. We know a lot of people are using social media to express their thought, feelings daily basis. These are the realistic thoughts and data of a person. So we can use this data to detect our depressed people. So the table of contents are abstract, introduction, methodology, workflow, and conclusion. So my abstract is the way of expressing various emotions and giving opinions has changed drastically with the advancement of social media and internet technology. Evidence shows that social media data provides valuable clues about physical and mental health conditions of individuals. It is feasible to identify depression at an early stage by mining online social behaviors. This research is focused on mining information over social networks such as Facebook, Instagram, and Twitter for sentiment analysis. A machine learning model is developing that is capable of analyzing discriminative features obtained from social media user data and determining whether a particular user exhibits depressive symptoms. This model can be used to assist medical professionals in the diagnosis of depression. The goal of this study is to explore negative or positive images and emojis in identifying the depression. So the introduction is rapid technological changes are altering people's communication styles. Social networks like Twitter, Facebook, and Instagram have become popular forums for people to share their thoughts, psychological behavior, and emotions. Social media may increase virtual connectivity among individuals. 3 types of data can be extracted from social media, such as text data, image data, and audio data. Text data includes the reviews, comments, responses. Image data includes the post, emojis shared by them. Audio data are the audio clips of users. So my proposed methodology is extract information over social networks such as Facebook, Instagram, and Twitter for sentiment analysis and developing a machine learning model that can determine whether a particular user exhibit depressive symptoms. Convolutional neural networks are one of the effective neural network that widely used for visual imagery, helping the computer identify and learn from images. So, in this study, CNN can be used to detect the negative or positive emojis as well as the post sent by them. Depressed users are always in an isolation mode, so they choose a shortest way to express their feelings than texting. Emojis are the only solution for them to express it in very short time. So they choose negative emojis such as loneliness, sad, depressed types. The CNN model recognizes and classifies these emojis to different categories. The post in the form of images can also be detected and classified. So in this way, we can detect the users who have high use of negative emojis and post. Those can be classified as severe risk, moderate risk, low risk, and no risk. So this is a workflow of my methodology, proposed methodology. So first we collect the user data and we pre-process the entire data. Then through the using the convolutional neural network model, we classify the emojis and the image post. Then we find a conclusion about the depression detection. These are my workflow and the conclusion. Detection of depression from social media is discussed in this study. Depression is one of the major mental disorder that faced by many people. Sometimes finding these people become a difficult task. Social media is the biggest platform to detect this. Evidence shows that social media gives us some clues to success in this mission. So mainly the platforms of Facebook, Instagram, Twitter are used to connect with others. Users share their comments, posts, reviews through this. In this study, we use machine learning to detect the depressed people. Convolutional neural network is a better way to analyzing the data. CNN model can classify both posts as well as emojis in an efficient way. Thereby, it gives a best result for the detection. So that's all about my proposed methodology. Thank you.
There's a question from Akash. You can see your chat box.
Oh, okay.
Akash, you can ask. Network problem is there, no?
Yeah, can you hear me?
Yes, yes, sir.
Yeah, I had a nice presentation. I just want to ask one question. Why is CNN is advantageous when you are dealing with images compared to the normal feed forward network?
Sir, not clear. It's break.
I posted the question in the chat. Can you see the chat?
Oh, okay.
Is the key difference between CNNs and normal feed-forward neural network?
So, okay. We use CNN here. That is, we need the accuracy. So, for image processing, CNN is widely used in machine learning model. Here we can see a CNN model can use to classify these images as well as the emojis. So when we train these data and when we test, we pass the data, we get the accurate result. So that we use the CNN for to increase the efficiency and the accuracy. Okay, sir.
Okay, there's a question. Okay, can you identify the area where its application is more relevant?
We can use this application in medical field to detect those depressed people. So rather than collecting all the users' data such as text, audios, it is simple to catch the images and the emojis and the images posed by them. So we already said that the depressed users are always in isolation mode. So they always use a simplest way to express their feelings. So emojis and a single emoji and a single post can tell all their feelings. So here we use this concept to detect the depression. So we can use this idea in the medical field. It will be helpful to detect those depressed people.
Specifically speaking, which branch of medical field?
In psychology analysis.
Okay, in psychiatry and psychology analysis. Okay.
Yes.
And is there a separate software which is needed to support this project for its outcome?
I'm just going to implement this. This is just my proposed, and I'm just going through this project. So I'm not sure about the entire software.
So how is basically the data is collected from that through social media interface framework or something other than that? That's what I'm asking. Is there a separate software to collect this, or from that media itself is collecting that information?
No. The data can be collected from anywhere. The project is entirely based on any social media, Facebook, Instagram, anything. Okay, so the data is available. The free data sets are available in Kaggle or any other sites. So we can use the sample first. When we take the sample of users, we can detect it.
So basically speaking, our data is basically fed to the server, and from there we have to collect according to our needs.
Yes, many Instagram APIs, Twitter APIs, all are available. Using that, we can collect the users' data.
Okay, fine. Thank you.
Thank you, sir.
Thank you, Ayana.
Thank you, ma'am.
Last call for Mr. Gautam, Sriraj, and Lakshya. I think they left from the meeting.
Miss, അവർക്ക് എന്തോ ഒരു ടെക്നിക്കൽ ഇഷ്യൂ ഉണ്ടെന്നാ പറഞ്ഞത് അവിടെ ജോയിൻ ചെയ്യാനേ.
നമ്മൾ വെയിറ്റ് ചെയ്യണോ?
വെയിറ്റ് ചെയ്യാൻ ഞാൻ ഇപ്പൊ കോളിലായിരുന്നു. ഞാൻ ഇപ്പൊ പറയാം കോളിലാണ് അവര് വിളിച്ചു.
ഓക്കെ വെയിറ്റ് ചെയ്യണേ, വെയിറ്റ് ചെയ്യാം. നമുക്ക് നോക്കാം. 5 minutes വെയിറ്റ് ചെയ്യാം.
മിസ് ഇപ്പൊ കേറാന്ന് പറഞ്ഞേ. അതിൽ ഒരാൾ മാത്രമില്ല, ഗൗതം മാത്രമില്ല, എന്തോ റീസൺ കൊണ്ട് ആൾക്ക് പറ്റിയില്ല.
Okay.
ലക്ഷ്യ കയറും.
Okay, okay. Welcome, Lakshya.
Ma'am, shall I start?
You can start now.
Okay. Good morning, one and all. Analysis of status of road accident occurrence and determination of the risk of accident by machine learning. Introduction. One of the most complicated and difficult daily need is
Can you present your topic?
Yes, ma'am.
Can you present your topic?
I am presenting.
സ്ലൈഡ് ഒന്ന് ഷെയർ ചെയ്യാമോ?
We can see your presentation.
Oh, I see. One second, ma'am. Can you see?
Yes, yes.
Yes.
Okay, ma'am. Analysis of status of the road accident occurrence and determination of risk of accident by machine learning. Introduction. One of the most complicated and difficult daily need is overland transportation. Turkey has been above 80 millions of vehicles recorded in Turkish National Police. Every year, 1 million vehicles are added to the traffic averagely. 1.2 million people have died and over 15 million people have been injured in road accident in the world every year. Studies on traffic have executed that road accident and death laceration ratio will increase. Design and control of traffic by advanced system come in view as the important need. Assumptions on risk in traffic and the regulation of inventions in the end of these assumptions will reduce road accidents. In assumption system which will be prepared with available data and new risk will be advantages. Data mining concepts have been come by increasing and storing data in digital stage. Data mining involving the studies which while cover information from systematic and purposeful data structures obtained from disordered and meaningless data. Machine learning, which is the sub-branch of artificial intelligence, supplies learning of computer taking advantages of warehouse assumption abilities of computer system have advanced in the accident data was studied to be found. Event of machine learning. Utilization of machine learning is widespread and functional method for taking authentic decision by using experience. Machine learning is also able to extract information from data and use static methods. The study on the analysis of road accident with tree-based models, classification of road accident with regression method, the connection between road accident and structure of the road, weather conditions, classification of road accident data with grouping method had a part in the literature of classification of road accident. In this study, machine learning algorithm, which is acceptable for accident assumption by the data mining method attaining from road. Data mining and machine learning. Data mining has been carried out in the field of retail selling, insurance, health, and banking, which comprises from wide data warehouses. For example, to identify purchasing habits of a customer, to determine the risk management and anticipate disease risk can be denoted. Data mining. Data mining must be prepared as following stages: data collection, data cleaning, data integrating, data decreasing, data transforming. Data cleaning is the stage that removes missing and noises. Also integrate the extreme data stage. The regaining of missing data, the entry of missing data can be taken out, can be completed manually. The same data can be entered and the missing data can be estimated by regression method. Data need to restructure according to the model and algorithm. In the study, algorithm has only 0, 1 data as well as other digital values to be transformed any data to acceptable data structure according to the algorithm. To be studied is called a data transforming stage. Machine learning is the branch of artificial intelligence, maintains the digital system, constitute models, and estimate the result which will occur in the new condition by using the data has been. The data model can be classified into value estimation and clustering. Association rule, a specified condition has been estimated by unavailable data in the valued estimation model. The clustering model has been supported by forming specific groups according to the similarity of data. Clustering algorithm has been taken into consideration in two groups as hierarchical clustering and non-hierarchical clustering. Association rules has been supported by principle that rules of forming conditions have been specified altogether. It is used to define purchasing trending of customers in retail shopping extensively. The classification method above mentioned will be used for the analysis of condition of road accident occurrence and defining the accident risk in the study. To find the algorithm which reaches the best result will be tried to be control the data with different algorithms. Algorithm for data mining classification. Decision tree classification algorithm, statistical classification algorithm, and classification algorithm for distance. The first one is decision tree classification algorithms. Provides to classify the tree type condition according to the answers. The algorithm consists of two stages which are occurrence of tree and trimming of branches. Result for the error with noisy data. It is the important determination which characteristics will be closed with the root and how the data will be divided. It is aimed to find correct and small nodal at the end of the stage. The algorithm of decision tree which is used at the most are CART. Statistical classification algorithm. The data classification according to their types and used probably calculus. This type of algorithm estimates the
identified categories the new data in concerned. In literally, Bayesian's 1R and regression algorithm are used in vast statistics. Classification algorithm for distance analyze distance and similarities of each data from one another. The classification of new data is estimated by being chosen to the closest neighbor in the specified number of sample clusters. Applying machine learning algorithm, identification of the problem. The study on reason and measuring the road accident are carried out. Classification methods such as raising the level of control, knowledge, and consciousness, and manufacturing the serious vehicles, secured vehicles, have been used to getting under control of road accident. It is seen that using the warnings related to road accidents will be benefited to control the road accident as estimated in to increase the effect of above mentioned method, which are troublesome and costly. Obtaining the data. According to the statistical data in Turkey, 37 road accidents of % have been happened in Istanbul. The study of SBM shows that the sample is sufficient. In the study, 500 accident samples was chosen for the data for road accident in Istanbul. The data in the study was being taken from the official report related to road accident record in Tremor, which is only foundation that connects the preserve the reliable data. The information above whether the condition was obtained from Turkish state meteorology service according to the information about the location and the time for accident obtained by trauma record, vehicle type, time zone, and weather condition for the accident were used to evaluate the process. Data processing. The first step required to pay attention is the data cleaning in the study of data processing. In this step, the missing data have been completed. It is required that the sample data cluster has been missing and false information. Also, the data for no accident classification is presented in order to be done classification and estimation. The data for the moments has been no accident is endless in real life. The classification of missing data was completed by using data from accident and data cleaning method. The random method was chosen in compulsion of data. The data obtained with this method was provided not to be in the class had an accident. The record of the situation has no accident was produced with this method. Modeling. After the data processing, modeling is made. ADA Boost CART C4.5 native base 1R IBK was are preferred at the most among the classifying algorithm will be used. The model which has been highest accuracy may be chosen according to the result of the algorithm. VK open source code software was used to order and discovered the result of data by testing with the algorithm. VK which...
Hello.
Hello.
The time has exceeded. Please come to the conclusion.
Okay. The use of machine learning is functional and extensive method in order to manage to be taken accurate decision in with experience. Evaluation and estimation with machine learning will bring scientific approach and opinion to the problem. Authentic accident data attained regularly may be used with the machine learning. The required precautions against the potential accident may be taken to recoiling
the risk of road accident. The web, mobile, and desktop software may be prepared for the accident risk estimation by using algorithms. The support of more confident traffic ambience and may be given by providing these programs to use the personal and institution. The controlling and arranging the traffic with advanced system have raised a more important requirement in parallel with increasing road accident. Even simple precautions and nature and confidential warning prevents the road accident. It is acknowledged that the estimation of risk of arranging the inventions to be made in the result of risk will be diminish these accidents. Thank you.
Any question?
Okay, there's a question. As you know, we already have a technology to ID the status of road accident occurrence and determination of risk of accidents. What additional feature does it put forth other than this?
We know that in Turkey and other countries that population and due to all these things, vehicles are increasing day by day, the use of vehicles. And as we know, our road are being damaged day by day. These all we needed for the future to be safe in road.
So I say, is the software dedicated only for that country, Turkey, or it's for worldwide?
No, we can adapt this system to our country also.
Okay, then what are the additional feature does it put forth? We already have the basic technologies to identify such things. Any additional features?
Playing machine learning and artificial intelligence, we can make it more efficient.
Mm-hmm. Okay, then what do you mean by association rule?
Sir, can you please repeat?
What do you know about association rule? What do you mean by association rule?
Association rule.
We have an association rule function in this algorithm.
Data mining?
Yeah, data mining. In data mining, association rule.
Classification of algorithms.
No, it's not that. Should I tell?
Yes, sir.
If something is associated with something, then another thing can also happen with that thing. അതായത് ഇന്നൊരു സാധനം ഇതിൻ്റെ കൂടെ അസോസിയേറ്റഡ് ആണെങ്കിൽ അതെടുക്കാനുള്ള പ്രോബിലിറ്റിയും കൂടുതലായിരിക്കും എന്നുള്ളതാണ്. അതാണ് ഇതിൽ വരുന്നത് അസോസിയേഷൻ റൂൾ എന്ന് പറയുന്നത്. അതായത് ഇപ്പോൾ കുഴികളുടെ കാര്യം പറഞ്ഞല്ലോ, കുഴികൾ ഇതൊക്കെ അടയ്ക്കാൻ വേണ്ടി കുഴികളുടെ അതായത് ഇന്ന കുഴികൾ കുഴികളുടെ സൈസ് കൂടുവാണെങ്കിൽ ആക്സിഡൻസിന്റെ റേറ്റ് അല്ലെങ്കിൽ ഡെപ്ത് ആക്സിഡന്റിന്റെ സിവിയറിറ്റി കൂടാൻ ചാൻസ് ഉണ്ട്. കുഴികൾ കുറവാണെങ്കിൽ അത്ര സിവിയർ ആയിരിക്കില്ല, അങ്ങനെയായിരിക്കും. അതായത് ഒരു അസോസിയേഷൻ ഉണ്ടാക്കി എടുക്കണം. അതാണ് അസോസിയേഷൻ റൂൾ ഇതിൽ വരുന്ന എക്സാമ്പിൾ പറഞ്ഞത് ഓർത്ത് വെച്ചോ. പിന്നെ പിന്നെ ഉള്ളത് വാട്ട് ആർ ദ ക്ലസ്റ്ററിംഗ് മെത്തേഡ്സ്? ക്ലസ്റ്ററിങ്സ് യൂസ് ചെയ്യണമല്ലോ. എന്തൊക്കെയാണ് ക്ലസ്റ്ററിംഗ് മെത്തേഡ്സ് ഉള്ളത്? എന്തെങ്കിലും അറിയാം? ഒരു ഒരെണ്ണം പറഞ്ഞാലും മതി.
ക്ലസ്റ്ററിംഗ് മെത്തേഡ്സ്
ഏതൊക്കെയുള്ളതെന്ന് മെത്തേഡ്സ് യൂസ് ചെയ്യുന്നത്? ഓക്കെ, ഞാൻ പറയാം. അത് ഡെൻസിറ്റി ബേസ്ഡ് ക്ലസ്റ്ററിംഗ് ഉണ്ട്. അതായത് എൻ്റെ ഡെൻസിറ്റി അനുസരിച്ചുള്ള DB സ്കാൻ, ഒപ്റ്റിക്സ്, HDB സ്കാൻ, ഹൈറാർക്കിക്കൽ. ഓക്കെ, ഇനി ലാസ്റ്റ് ഓർമ്മ കൂടെ ഒരു ക്വസ്റ്റ്യൻ കൂടെ ഉണ്ട്. ഈ കാർട്ട് അൽഗോരിതം എന്ന് പറഞ്ഞു. എന്താണ് കാർട്ടിന്റെ ഫുൾ ഫോം? എന്താണ് ഫുൾ ഫോം ഓഫ് കാർട്ട്?
കാർട്ട് അൽഗോരിതത്തിന്റെ ഫുൾ ഫോം?
കാർട്ട് അൽഗോരിതത്തിലെ കാർട്ടിന്റെ ഫുൾ ഫോം?
അതെന്ന് പറഞ്ഞാൽ ഒരു സെറ്റ് ഓഫ് ടെക്നോളജി ആണെന്ന് അറിയാം.
ഓക്കെ കുഴപ്പമില്ല. അതിന്റെ ഫുൾ ഫോം എന്താണെന്ന് അറിയാമോ? ഇതിൽ തന്നെ നമ്മൾ ഉപയോഗിക്കുന്ന ടേം തന്നെയാണ് ക്ലാസിഫിക്കേഷൻ ആൻഡ് റിഗ്രഷൻ ട്രീ എന്നാണ് ഫുൾ ഫോം. ഓക്കെ, ശരി, താങ്ക് യു. എനിക്ക് അത്ര
Thank you, Lakshya. Our paper presentations over.
Thank you all for your participation. Now I invite Ms. Vishnupriya KS, Department of Computer Science, for the vote of thanks.
As all good things come to an end in life, so is the seminar. On the behalf of St. Stephen's College, Uzhavoor, I take this opportunity to propose a vote of thanks who have directly and indirectly contributed to the international conference QUAESITIO 22-23 organized by our institute. At the outset, I thank our chief guest and resource person, Dr. Shailesh, Assistant Professor, CUSAT, and a special thanks to Sri Agash Dominic Thomas for your presence. We are really enlightened with your knowledge and presence, sir. I would like to thank our principal for his enthusiastic support. I would also take this chance to address a takeoff of gratitude to Manoj Yeshod, the head of the department, along with Tina S. Nair and Harish Sabu, to make this event such a resounding success. We are thankful to the researcher and to our honorable research coordinators for their immersible motivation. A special thanks to the organizing committee, teaching and non-teaching staff for their unflinching support and coordination. I have also obligated to the presenters who have conveyed their thoughts and suggestions, which helped us to move forward. Once again, I thank you, each and everyone, for their time and hard work. Thank you.
Thank you, Vishnupriya.
Okay, we can leave the call.
Okay, now let's conclude our session. Thank you all.
Thank you all.
Thank you.